Here. Thanks for coming out. This is Going Off the Rails on a Crazy Train. Just a brief introduction for who we are. My name's Tomek. I'm a senior security consultant at NCC Group. I used to be a Rails developer. Now I break Rails apps more or less for a living. This is Jeff.
I'm Jeff Jarmoc. I'm also with NCC Group. I've done a lot of Rails-related work, contributed a couple modules to Metasploit that are Rails-related. Have worked on Breakman a little bit, various other things.
Okay. I don't know if this needs to be adjusted here. So yeah, we're from NCC Group, headquartered in the UK. We're both from the Chicago office. Do software escrow, testing, domain services. So let's hop into the outline of what we're going to be going over here. So I'll just go over a brief introduction to Rails. Jeff's going to hop into authentication. I'm going to talk about authorization, and then we're going to do a demo of a dynamic analysis tool that we wrote to make testing, authentication, and authorization easier. So when you start off, Rails is an MVC framework. So this is the kind of the output that you'll start seeing for the directory structure when you run the command Rails new sample app. In the main app directory, we're just going to go over the files that we kind of are going to care about for this talk. You got the models directory, so the models are going to be mappings of objects to database rows and tables. And then you got the views, that's going to be the templates that the client are actually going to see when they go to your website. And the controllers, that's the piece that glues the model and the views together and kind of gets everything ready to present to the user. In the configuration directory, you have the routes file. This is going to be, we're going to go over this a bit later, but this is a mapping of all of the URLs in your application and to which controller actions they map to. The gem file is going to be pretty much a list of libraries or external gems that your application uses. So this is going to be interesting to see, are they using like devise or can or pundit. The gem file.lock is going to give you the specific versions of those gems. So then you can start looking for things like, if there's a specific version of this gem that's vulnerable, you can look in the gemfile.lock to see kind of what version they're using. So the Rails way, Rails is kind of nice because it provides a lot of protections for developers by default. So here we kind of have the MVC architecture coming out again through these three different mechanisms. So active record is how the models are set up in Rails. That's going to give you SQL protection by default. Now there are ways to get that wrong. So we have a link there for railssqli.org. That's a pretty comprehensive list of how you can still get SQL injection in Rails applications. So we refer to that pretty frequently. Action view is going to, by default, HTML output encode user input. And again, there's ways to do that wrong, but if you just kind of use the framework as it's intended, then you're going to get XSS protection by default. Action controller is going to give you things like CSRF protection by default through things like protect from forgery. So just going to kind of start going into authentication here.
All right. So, as Tomek said, like Rails gives you a lot of security protections kind of out of the box. But where it kind of goes off the rails is when it comes to authentication authorization. That's something that most, reasonable applications are going to need to have a concept of a user and what their permissions model is and things like that. But there's really not a lot of native support in Rails for either. So the first point is that authentication and authorization are two distinctly different things, right? So authentication is focused on who is the user, just on identifying them, and then authorization is, what permissions they're allowed. Oftentimes I see that people mix the two together into a single, auth, and that can sometimes be a little bit of a source of confusion. On the authentication front, all that you really get out of the box with Rails is HTTP, basic auth, digest auth, which you probably don't want to use. On the authorization front, there's really nothing native, but there are some helper methods and things that we'll talk about that can help. So you're kind of left to come up with your own authentication system. So you have two options, and the first is to write your own authentication system. There's some pros and cons to that approach. You're kind of reinventing the wheel and doing things that people have done before. So you're kind of likely to fall into some common pitfalls that we're going to talk about. There's also a lot more to authentication than just verifying who the user is, and a lot of times people don't think about some of these other, ancillary features. In Rails, since 3.1, there's a helper method called hasSecurePassword that we'll talk about in a little bit more detail, but that can make it easy to get kind of a simple authentication function built pretty quickly. Your other option is to take an off-the-shelf gem that someone's written, open source, and use that. Again, pros and cons. So vulnerabilities in gems tend to be really attractive, to attackers because, they're common across a lot of different applications. But on the other hand, and for that reason, you kind of have to make sure that you manage your dependencies and, and keep updated as new versions are released and bug fixes and things like that. You're still going to have to do some work to integrate a gem into your own application, and there's some caveats to that to be cautious of. But on the plus side, the core code in popular authentication gems is generally pretty well reviewed. There's a lot of eyes on it, sort of the many eyes makes all bugs shallow theory. And then as the community learns new things, vulnerabilities are found, they're fixed, and over time the whole thing gets a little bit better. As a result of that. So some of the common authentication gems, Devise is really the big one. It's safe to say that the vast majority of Rails applications are using Devise for authentication. OmniAuth is, an OAuth consumer. So if you want to do things like, allow users to authenticate with Facebook or Google or something like that, OmniAuth is really, the common one there. There's some hooks in Devise that allow you to call back to OmniAuth so the two can work together. So you can have Devise for your standard, username, password authentication, and then have it call OmniAuth automatically, if you're doing OAuth authentication. Doorkeeper, the third one there, is a little bit different because that's an OAuth provider. So instead of allowing users to authenticate with, Facebook or Google, it allows you to become the provider, and other applications can consume that. Auth Logic is, one of the other popular gems. It's not nearly as common, and it's a little bit different in its model. That it kind of blends sessions with authentication rather than implementing it as part of the user model. So it's a little bit unusual, and I don't see it quite as often as Devise, but it's worth noting. There's obviously any number of other gems, but these are kind of the really popular, common ones that we see a lot. When it comes to writing your own authentication, there's a lot of arguments that people commonly make. This is a quote from the Rails tutorial book. It's also available freely on the internet. So it's a really popular, introduction to writing Rails apps. And it's kind of the Bible of how people code Rails. But they say a couple of things here about writing an authentication system. Authentication requires extensive customization. Modifying a third-party product is more work, and off-the-shelf systems can be black boxes. And these are things that we hear a lot when we talk to clients and they're describing their approach to authentication and why they've chosen to write their own. I don't really agree with these arguments for the most part. To say that an off-the-shelf system is a black box can certainly be true, but that's just as true of Rails itself as it is of a third-party authentication gem. As far as it being more work to integrate a gem than write your own, that to me is just flat out false. It is some work to integrate a gem with your application, but it's not nearly as much work as as writing a system from scratch and making sure that you get all the little details and nuances right. But when people talk about writing their own, I mentioned hasSecurePassword earlier, and that's a really useful helper method. So this is kind of an example of how you'd use it. We've got a user model that's got a really simple schema with 2 strings for name and password digest, and in that model you just include hasSecurePassword. What that does is it allows you to do things like this. You can call user new to create a new user. pass it a name, password, and password confirmation. You'll notice that the schema doesn't actually have the password or password confirmation fields. Those are provided by the has secure password helper, which transparently then uses bcrypt in the background, taking the password confirmation, making sure they match, bcrypting and storing a digest securely. So right there, you've got a pretty decent, password storage system with, one line of code. Then you save the user, it returns true, and you're all set. As I mentioned, the digests are stored with bcrypt. It's a reasonably secure password storage mechanism. I wrote a really long blog post talking about kind of my thoughts on password storage. So if you're interested in more, there's a link to that. Some of the other things you get with that has secure password, you get an authenticate method that you pass the password to the user model's authenticate method, and it returns false if it's wrong. If it's correct, it returns the user model itself. So you've got a really simple authentication function. You can also do things, since you're inheriting, the model inherits from active record, you get all your active record, finders. So you can, do a query on the user class to, find the user by name, and then call authenticate. And if the password matches, it's going to return the, the corresponding user object. But there's still a lot more that you need to do. Storing credentials and authenticating is really just an authentication function. It's not really an authentication system. So you're definitely going to have to think about things like, session management, password complexity requirements, what you're going to do in the case of a lost or forgotten password. And that's a really, really big one. Depending on the application, you might have to deal with things like API tokens, multi-factor, two-factor, we mentioned OAuth earlier. So this is really just the beginning. So let's talk about session management as being kind of the next thing you need to do. So sessions are basically the idea of exchanging user credentials for a cookie, for a token, and then using that token to identify the user in subsequent requests, so you're not exchanging credentials on every request. Step 3 there is kind of important, and people forget about this a lot, that you need to invalidate the token at some point, whether it's when the user logs out or, after some period of time when it's just expired. And in Rails, there's a couple of different approaches to where session state is stored. And so we're going to spend some time here talking about that. The current default is encrypted cookie sessions on recent versions of Rails. So we've got an example here. We'll kind of walk through the flow. You've got a simple sign-in page. The user comes and provides their user ID. They give their password. It's sent to the application that looks up the user by their ID, authenticates them using that password. Assuming that's correct, the user model is returned, and there's a session object created on the server side. With encrypted cookie sessions, that session object is then serialized, encrypted, and presented to the user as their cookie. So the important thing here is that the cookie that the user has is literally an encrypted serialized object that the server is going to use to create that session. The next option then is database backed sessions. So we've got kind of a similar flow, but in this case, there's a database on the server. Again, the user is going to provide their password, authenticates by that password, creates a session object that's then stored in the database. There's also then a cookie stored alongside that session object, and then that cookie value is provided, to the user. So that's just a random token that then allows the application to look up that session object in its own database. So on subsequent visits, the user is going to provide that random token. The database is going to do a query, retrieve the session from the database. So there's pros and cons of each of these approaches. On the database front, the user cookie is just a random value. As I mentioned, on the serialized cookies, it's an encrypted serialized object. I've italicized here the database column because I feel like that's a win for database sessions, that there's a little bit less, attack surface there exposed. moving on, when we talk about like how we're going to revoke the session, with database sessions, you can just delete the session from the database and it's gone. On cookie sessions, it's a little bit more complicated because, once that value is given to the user, you really can't revoke it. So you have to have things like, a timestamp in it that can expire, or some other token included in that session, On both cases, you're going to need to be conscious of, having a maximum lifetime to your sessions. Neither one by default is going to do that. So we'll talk about how to configure that in a little bit. I mentioned the attack surface. Again, I think this is a big win for database sessions. The only way you can really attack that is to steal or enumerate that random token. With the serialized sessions, you've still got that option. You also have the possibility of, cryptographic attacks against the session object itself. You've got a higher probability of longer infinite lived sessions because of the revocation issues. If the encryption key is ever exposed, it's fatal. Then I can create my own sessions arbitrarily and the application will honor them. And then there's also some issues surrounding the serialization. And that kind of relates to some of the Rails deserialization issues from a couple of years ago. And we'll talk a little bit about that too. The overhead here is kind of the big reason that people tend to favor encrypted cookie sessions. With database sessions, on each request, you've got to do a query to retrieve that object from the database so that you can identify, the context of the user session. So there's a lot of overhead involved in that. Caching can help. I've heard of people doing things like in-memory databases to try and reduce the overhead. And Active Record in recent versions of Rails has had a lot of caching and performance improvements. So I don't think that the overhead is all that bad, except on really large applications. But for this reason, database sessions are no longer included in Rails by default. There's a separate gem that you need to include. And I'm a little bit disappointed by that because, while there are performance issues on large applications, I feel like, there's a small percentage of times when that's really a practical concern to developers. And so removing it, from even being an option in the framework seems a little heavy-handed. On the encrypted cookie sessions, you've still got some overhead with just, validating the cryptographic signatures, decrypting the data and then deserializing it. I haven't really done the measurements to compare the two directly. So I'm going to trust the Rails team when they say that, database sessions are more overhead, but, I kind of question exactly how much. At some point, I'll probably do the math to figure that out. Okay. So, we talked about having a couple of different types of sessions. Those are going to be configured in your, session store initializer file, with a line that looks a little bit like this. You'll note there on this particular one, we've got the session set as cookie store. And then I bolded the expire after setting. That's not there by default. So if you don't have that there, your sessions are going to live forever. So that's one thing when you're assessing applications you want to look at, and is there a session timeout? Obviously you can do that black box, just have a session active and wait a while and see if it's still honored. But it's a lot easier to just look at the source. So session expiry time has to be manually configured. That cookie store setting is where you would change your session storage type if you wanted to use Active Record Store. You do still have to include the gem in the application to support that. Okay, so with cookie sessions, you're then going to also have a setting in secrets YAML that contains your secret key base. That's the encryption key that's used for encrypting those sessions. So you want to make sure that that's a fairly secure value and that it remains secret. If instead you have a secret token, you don't get encryption at all. What you end up getting is just an encoded serialized session. So that's kind of interesting because if they're storing sensitive data within the session object, you can take that cookie, just base64 decode it, and you've got a serialized object. So you can get a little bit of exposure of sensitive information that way. Within the Session store initializer. You also have a setting here that determines what the serialization method is for that session. Currently, it defaults to JSON. This is the case since Rails 4.1. Prior to that, it defaulted to Marshall. Marshall load was the vector for the Rails YAML deserialization vulns of 2013, I think it was. So if it's set to Marshall and I know the encryption key, I can craft a malicious session object that when deserialized is going to execute arbitrary code on the server. It's not quite as bad as the original vector because I do have to have that encryption key, but if that ever leaks, not only can I craft session objects, I can also get code execution on the server. This hybrid serializer is kind of an upgrade path. So in hybrid mode, the application is going to issue JSON serialized cookies, but it's going to honor either JSON or Marshall serialized cookies. So it's meant to, to allow you to migrate transparently. I've seen a number of applications where people have turned on hybrid mode to facilitate the upgrade and just left it. And you still have the vector there for RCE where, even though the application's not issuing Marshall serialized cookies, if it honors them, I can still get code exec. It's kind of interesting. You really don't need to have that hybrid mode for very long because if you have a maximum lifetime configured on your sessions, you're only going to need to honor the legacy Marshall sessions for the duration of your session lifetime, because at that point they're all expired and you're never going to see them again. So it's really the sort of thing that you probably only need to have, have enabled in production for a couple of hours. But a lot of times people just, don't go back and clean that up. So that's something to watch out for. We talked a little bit, I mentioned lost, forgotten password recovery is kind of difficult. There's a lot of different approaches people use to handle this. Most of them are kind of poor in one way or the other. There's really only one approach that I'm fond of, and that's this process. Generate a random token, and you want to make sure that that's generated with a cryptographically secure random number generator, so it's not predictable. Send that to, store it in the user object along with the timestamp of when it was created. Send it to the user out of band from the application. So this is the usual, you get an email with a link that says, click here to reset your password. The user's then going to visit the site, present that token. Application is going to look up the user by that token, verify that token, the timestamp on that token that was stored is within an expiry time. You don't want these things to be valid forever. If I issue a reset token and, then forget about it and never go and reset my token, you don't want that sitting in my email box and being valid, days or weeks later. And then you change the user's password and delete the token. That's another caveat, that people often forget. After the password's been reset, you want to delete that so that someone else can't reset it again using the same token. So let's change gears and talk about devise a little bit. I mentioned that that's the way that, the vast majority of applications are gonna handle authentication. So we've got an example here of a user model that was generated by devise when it's installed. And it's really simple. It's got this devise helper that, includes a number of symbols here that represent different modules that devise has to include various functionality. The names here are pretty self-explanatory, explaining what they do. Registerable allows a user to anonymously visit the site and create a new account. Database authenticatable is, kind of self-evident. It's the main authentication mechanism. Recoverable allows for a password reset flow when a password's forgotten. There's a number of other modules here that are commented out that just aren't enabled by default. So it's kind of nice that you can just enable and disable these modules and get different different components of functionality. Once you've got devise installed, if you look at your routes RB, you're going to see a line that's devise for users, just that one line. This calls this devise helper on your user model. And the effect of that is going to be if you run rake routes and see which are actual, routes that the application has configured are, you see this. So you've got a whole number of different routes with, various methods. And these do things like, give the user a sign-in page, accept their credentials and authenticate them, present a password reset flow. So without a lot of work, you get a lot of functionality. So then tying devise to the application, you've got a bunch of helpers provided. The main thing is this controller filter. You're usually going to see this implemented as a before action in the application controller that all the other controllers inherit from. And that's a really easy way to just say, okay, across the application, we're going to authenticate users. We'll talk a little bit about that on the authorization side. The other helpers then are, pretty well named. User signed in returns a Boolean of whether the user signed in or not. Current user session return, the current user in the user session. Current user is really the big one, because you'll see most of your queries are going to be built from that object as the root. Devise has a bit of a security history. This is a snippet of some of the recent versions that have had security relevant changes. The key point here is that most of these are really kind of minor flaws, and they're the sort of things that are really easy to get wrong, but over time, community is kind of benefiting from improvements in Devise. The two that are bolded, I'm going to talk about over the next couple of slides. Storing HMAC of reset tokens now instead of the raw value of the token itself. And then there was a type confusion vulnerability. I'm going to spend a couple of slides talking about this. This is a really interesting vulnerability. It was disclosed in 2013 by Jorn Chen. So let's look at how that works. Roughly, Devise's password reset function is going to look something like this. This is kind of pseudocode. It's split across a number of different, different classes, and it's a lot more complicated. But the basic idea of it is that, when this reset method is called, we're going to get the user's reset password token from the parameters, look up the user object associated with that token, and then, if it exists, we're going to change the password to the new value. With that in mind, the bug actually stems from MySQL's equality operators. So this is really not what I would expect. When you do a query where the integer 1 equals a string that starts with 1, it's actually true, and it's going to return data. Similarly, the integer 0 is going to be equivalent to any string that begins with a non-integer character. I don't get this. I have no idea why this is the case. But that's how MySQL's equality works. And it doesn't seem like they're likely to change it because it's going to break all kinds of things if they do. But that's really the root of the bug. Yeah, right. Like, yeah,
that functionality right there. Yeah.
It's so like, what? But anyway, how do we exploit this in Rails and in Devise? In Rails, there's this hash called params that's usually a bunch of strings that are the user's URL parameters. So if you've got a query with foobar or fizzbuzz, you get a params hash where foo is bar and so on. If you pass integers, as in the second example there, it's interesting to note that those are quoted, so they're strings. Even though it's an integer value, it's handled as a string in the params hash. We don't need strings here. We need to get integers for that MySQL confusion. There's some Rails magic that lets us do that. Rails will, when it receives a post with an XML or JSON body, it's going to automatically parse that body and typecast things as XML or JSON formats dictate. XML is no longer supported out of the box in 4.0 and later. There's a separate gem to enable it, but that was kind of disabled again as a result of the XML deserialization vulns. JSON, however, is still supported automatically out of the box on all versions of Rails. So if we send a post with the XML example like this, with an object foo, on fizz, you'll notice we specify the type as an integer. Then we're going to get back a params hash where fizz is the integer one. So now we've got integers in the params hash, and that's kind of the first step. Similarly with JSON, if we send JSON like this and just don't quote the reset password token, it's going to come through as an integer. So now we've got the integer 0. So if we send something like this to the application, what we're going to end up with is params hash, where we control password confirmation, and reset token is the integer 0. As a result of that, the active record query is going to do a find by token with the integer 0 as the argument. Active record is then going to build a SQL query that that looks like this, where token equals integer 0. And the result of that is that we're going to get back the user object of the first outstanding token. And there's a little bit of a caveat because due to the comparison, this is the first outstanding token that starts with a non-integer. But in most cases, your tokens are generally not going to have integers, or if they do, they're only going to be, 1 or 2 digits deep before it's an alpha character. So that's kind of interesting because now we've got a user object from a password reset token that we didn't know. So that's the core of the vulnerability. I wrote a Metasploit module for this a couple of years ago. The Metasploit module will loop through and monitor the response codes to clear out any existing tokens. The benefit of doing that is that then we can send a password recovery request for a given user and know that that's the only token outstanding. There's a little bit of a race condition there if the applications, other people are requesting things at the same time. But generally it's fast enough that, it's not going to be too much of an issue. Once we've got an outstanding token, we can go ahead and reset the password without knowing that token. The caveat to this is that the legitimate user of the account is going to get an email. There's nothing we can do about that. They're going to get the password reset email with their token. But I think, by the time they see that, you're generally going to already be in. So yeah, that's kind of fun. So why are we talking about this? This vulnerability. It's from 2013. It's patched in recent versions of Devise. The Devise patch, all it really does, and I should go back to that pseudocode. Where is it? There we go. So I said that the reset method looks something like this. The patch essentially takes that find by token and adds a toString. So it just casts it, explicitly to a string, so you can't get integers through. That's how Devise patched it. Rails also, let's see. Oh, okay. Well, I'll make this point before I move on to that. The core vulnerability here being in MySQL and, due to active records queries affects a lot more than just Devise. So while it's a couple of years old vulnerability and, most people have upgraded Devise in the meantime, you see that same thing a lot of times when people write their own, their own recovery functions, API tokens, reset tokens, things like that. So it's a good one to be aware of. That Metasploit module can pretty easily be tweaked to interoperate with different endpoints, that would be vulnerable to the same issue. I talked about the Devise patch. The Rails, fixes for this are kind of interesting. In Rails 3.2.12, they pushed a change that would cause Active Record to build its queries using the type of the database schema. So if it's looking up a string in the database, it would cast the parameter to a string automatically. They ended up reverting that in Rails 3.2.13 because it broke some other functionality. So on the 3.2 branch, there's really only one version where that function is enabled in Rails. 4.2 and later, however, we'll build queries that way out of the box. So that's an improvement. But even on 4.2 and later, if you build your queries using something like where, you can still introduce the same sort of issue. This is a parameterized query, so it's not SQL injectable, but I can control the type of the parameter, and that's really all I need to exploit something like this. So with that, we're gonna move on to authorization. Tomek's gonna talk about that.
All right. So now that we have a user that's ultimately authenticated, let's go over authorization. So I kind of think about this as what can they do? And this tends to be tied to the concept of roles within applications. I like to break it down into two separate groups. So you have the notion of vertical authorization. So in the examples here, you might have a site admin that's full access, an organization admin that's going to have more granular access controls applied to it. Maybe full access to a specific organization. A regular user who's going to have limited read access, and then unauthenticated, who should have no access to anything. Horizontal authorization, on the other hand, is a regular user in organization 1 shouldn't be able to see the data of organization 2. So what does this look like in authorization? We tend to see that for vertical authorization, that gets implemented with the use of before actions. So here we have some examples. At the top, you might see something in a controller that says require admin. So before actions is pretty much a method that's going to get run before any action is called within that controller. And then you can specify options to say things like only or except if you only want the actions, the before actions, to be run on certain controller actions. So for horizontal authorization, this tends to get implemented with the use of associations. So we had the notion of a current user object in devise, and then what you're going to do here is say, okay, for the current user, let's get their organization, get all the posts within that organization, and then do our lookup methods on that. So what that does is it pretty much keeps the subset of data that's going to get queried to things that belong to that user. So going into how routing works in Rails, we're just going to briefly go over this. This is going to be a line that you'll see in the configuration file in routes.rb. And so it's pretty simple here. You have your HTTP method, the path that you want to expose in your application, and then you point it to the controller and action. And here this is the notion of controllers at class, and an action is a method within that class. So this is going to be a typical Rails controller. You'll see that it's inheriting from application controller here. Index is going to be the method within this class that's going to be exposed. And so that's the action in Rails. But yeah, so you'll notice the use of the application controller here. So we'll kind of go into that and talk about controller hierarchy. So the application controller is the main kind of class that by default all of the controllers are going to inherit from. So it's very common that you're going to see kind of site-wide authorization and authentication before actions within this. You're also going to get things by default. So that protect from forgery line is just generated when you generate the application. So again, going back to the post controller, that's going to inherit from application controller. And then as you go up, you have more lighter weight classes, and so you're going to start losing functionality that you get by default. So for example, we sometimes see applications where people inherit from application or action controller base, and so they're going to lose things like CSRF protection. So going into how callbacks work within Rails. You tend to have 3 different ways that you can apply this. So you have before, around, and after. But with the way that authorization tends to work, you want to authorize the user before you start running any code that might change the database. So we tend to focus on before actions. And you're going to see this in a few different flavors. We kind of touched on this earlier. But you can say only or except, which is going to be pretty much an array of actions to say only run it on these or run it on everything except these actions. You can also provide other conditional methods and say, if this method returns true, run this before action, or unless. You can also skip before actions. So you can say, if you have the application controller and it's calling authorize user, which means that it's going to get run on every single action by default, you can say skip the authorize user before action on specific controller actions. You'll also see things like you can pass it a proc with custom authorization logic if it's small enough that it's going to fit there, but this is pretty rare. So there are some authorization gems for Rails. Pundit and Can, formerly Can, are two of the more popular ones. So Pundit, you're going to see something like this where you look up a post object and then you call authorize on that. And so that's going to be an actual method call within the controller action itself. Can works in a very similar way, but you kind of specify the actual ability as you call the authorize method. And it provides some helper methods as well, like load and authorize resource, which is smart enough to know that, hey, you're probably looking for a post object, so I'm going to load that by the ID param and look that up and authorize the user. Just a quick note on that. Although Pundit and Can are pretty popular, I think we tend to see more often than not that people implement their own authorization logic. So we're kind of go over things to be on the lookout for. Calling find by methods directly on models. So we kind of talked about associations earlier. This is just something to be on the lookout for. It's not automatically going to be a vulnerability, but when we find authorization flaws, it's going to be around patterns like this. So we like to see, again, the use of associations, limit the subset of data that you're querying to ones that belong to the user. So be on the lookout for whitelisted actions. So here we're saying authorize author for only the update, destroy, and create actions in the post controller. So you might think about the scenario where developer comes in, adds a new controller action, and they don't add that new controller action to this list. So that's what you might find an authorization bypass around that. So we tend to like more kind of like a blacklist approach where you're saying run this authorize author before action on every single action of the post controller automatically except for the ones provided. So in that same scenario, if the developer comes in, adds a new controller action, they have to explicitly add it to this list so that it doesn't get run. Lightweight controllers, I touched on this a little bit earlier, but the farther you go up that hierarchy, the more you're going to lose here. Again, inheriting directly from action controller base, you're going to lose things like CSRF. Now, that doesn't mean that's going to be a vulnerability necessarily, because you might want this for things like APIs, right? But when you get down to like action controller metal, you just lose the ability to even call before actions because that's a middleware. So you would have to include that explicitly. So yeah, if you see a controller that just inherits from application controller, you're probably not going to see anything too wonky around that. Authorization logic in views. So again, this is developer is correctly checking for roles, seeing if they're an admin, but they're just showing and hiding that in the view. And so on the back end, you want to ensure that in the actual controller logic that corresponds to this view, you want to make sure that they're properly checking roles there as well. The use of skipping of filters. So again, this is just more try to vet it if you see it, because you want to make sure that the developer actually meant to do this. So sometimes we might see things like developers trying to test with like a curl client. They don't want to play around with authenticity tokens, so they'll say skip before action, verify authenticity token, and then forget to take that back out when they commit it. And so then you have CSRF across that controller. Rails scaffolding is really nice in the sense that it allows you to get controller actions up and running very quickly, and it'll generate things like views and controllers for you. The problem is that it generates some artifacts that developers don't really know about. And so here we're just running Rails generate scaffold, and then you kind of specify the attributes for that model. And again, it'll go through, generate the views, these JBuilder files, and then the active record models. So what happens with that is that, for example, for the JBuilder files, this is kind of a view template so that when you request a JSON response, it'll generate this and then add all of these attributes automatically. So every single attribute you generate in Rails scaffold will be available by default. So if you have some secret token or something that you don't want users to see, it's going to show up automatically. In the same way, for strong parameters, which is kind of the protection for mass assignment vulnerabilities in Rails, all of the attributes will automatically get added to the permit method. So every single attribute is going to be mass assignable. So yeah, those are going to be some of the patterns. We're going to talk about Boilerman right now. So we only looked at one controller, the post controller. If you can imagine checking every single before action for every controller in an application, it can become a pretty big hassle here. So Boilerman tries to bring every single before action across every controller into one place that you can query and look at dynamically. So just a bit about how it works. It plugs into existing Rails applications, and it gets mounted as a Rails engine. So you do need pretty much shell access to the application. With Rails assessments and it being more towards the startup kind of crowd, our clients tend to be pretty open with giving us full shell access to their box, or they just quickly stand up like a staging instance. So yeah, again, as a minimum requirement, access to the Rails console is going to be needed. But yeah, once you have it mounted, you can just go to /Boilerman in the application and then start running through it. So I'm actually going to go through a quick demo here about what this looks like. Nice. All right, so the example I'm going to use here is RailsGoat. So RailsGoat is an intentionally vulnerable Rails application, kind of released through the OWASP organization. So this is a full application. If you guys are interested in ever testing Rails apps or getting started doing security assessments, you can get this up and running really quickly, and then start going through some common Rails vulnerabilities. But yeah, this is a full web app. You can kind of log in and play around with that. But if we just go to /Boilerman here, I've already installed it into this application. You're going to start seeing, this is the main view. So you have basic filters to say, show me only the controllers that include a string, give me every action that has a specific before action or without one. So here you're going to see a table breakdown of every single controller and every action on that controller. So here we have the controller, here's the forgot password action, and here are all the before actions that get run. So I don't know if there are any people out there that assess Rails applications for a living, but could anyone spot a vulnerability right now based off of an action that should probably get run on every single action controller? Well, so it's not actually here is the thing, because these are all the actions that are getting run. Exactly, yeah. So by default, if we look into the application controller, we'll see that it's commented out here with some note about security guys talking about sea surfing. So if we uncomment this out and refresh the page here, we'll see verify authenticity token is automatically added to every single action. So it's kind of nice to be able to spot things like that automatically. But we have an example here. So there's a mobile API endpoint available here. So if we look at API, we'll see there's an API controller available for users, and then one available for the mobile controller. So if I kind of open up, so rake routes is really nice. Rake routes is going to show you every single controller action here. Oh, this is not going to show well, is it? This is pretty much something I ask every client straight off the bat, and it's going to show you every single path in the application, so you don't have to enumerate them manually. But if we look here, this isn't shown too well. I don't know how well this is going to come up. But we have this kind of So if we say API v1 users, so this is going to go to the user's action or the user's controller with the index action. So if we pull that up here, we'll see things like valid API token. So I'm pretty certain that that's going to be some kind of authentication type action. Let's see, we'll go here. API v1 users. So here we're getting HTTP token access denied. So that's probably going to be from this valid API token. If we look up the actual user's controller, we'll see that they're saying before filter valid API token. And so if we look at that method, they're doing some kind of authentication around that. So I'd want to say, I'd probably want to find any API controller actions that don't call this method. So if I go back up to the filters and say, for the API controllers, give me every single action without the valid API token. And we'll see nothing comes up in the user's controller, but every mobile controller controller action is going to be seemingly vulnerable and has no authentication. So if we go back to the rake routes and we pull one of these guys, we get a null response here, but you see that we're no longer getting the HTTP token error back. So if we look at the mobile controller for our index action, which is what we've just called, we'll see first there's no before filter that's expected. And then in the index action, it's requiring this class parameter. And ultimately what's going on here, this is a bit of a non-standard code pattern. You're not really going to see this too often, apart from the dynamic classification, I guess. But they're saying, given whatever class you pass in as a parameter, turn that into a class, constantize it, and then just call .all on it, which is going to return everything for the provided class. So we can do something like class equals user, and it'll call user.all and return everything here. So that's the demo. But if you kind of assess Rails applications for a living and see this, like this should already be something really nice that hopefully is going to be useful. It's a new application, so it's going to be a bit rough around the edges. But I encourage anyone who assesses Rails apps to use it. Ping me if you ever see anything wrong with it. But again, to use it, you can do gem install boilerman. But primarily, you're going to add it to the gem file of your Rails application and then run bundle install. The takeaways is even if you don't use Brakeman, Rails console is extremely powerful in assessments. That's kind of where this tool came from. I just started kind of playing around and then realized, like, hey, you can pretty much query programmatically any aspect of a Rails application if you have access to it. Future ideas, adding some D3 visualization. We're kind of working on it on the way up here. But didn't get it quite done. Source querying is going to be coming soon as well. So in the cases of like Pundit and can, you can say, give me all the controller actions that don't call authorize. But yeah, that's everything. Any questions? Yeah, actually I think I was supposed to do that. I'll show that really quickly here. So yeah, if you don't have access outside of the app, you can run it through Rails console directly.
Well, it runs dynamically, like within Rails, so you do need to like have the ability to run that. Brakeman is static.
Yeah.
Right. Yeah, but Brakeman is static analysis, so that's just parsing the code and doing it. Whereas this is actually like loading it within Rails and then walking the tree. So you do need the app running. It's a little bit different.
Yeah, and there are going to be some cases where you might have shell access to the box, but for one reason or another, you can't add it to the gem file and relaunch everything. So you can force sideload it through Rails console, and I have some instructions on the README on how to do that. But yeah.
You want to pull up the Rails console? Show everybody?
Yeah, so I mean, this is the Rails console. If you don't want to use the actual. Okay. Sure.
All right. Thanks, everybody.
Thanks. Cool.
Yeah, you got an hour. You got an hour. Yeah, you can keep on going then. Oh, okay.
We had lunch.
Pull up the console.
Yeah, no, I mean, so this is, you can just kind of programmatically get this here, but
You're not mirrored.